This should take you a few moments to read, so seriously, please do pause the video and take a second to read it thoroughly. Ready, set, go. So we've got a pool table. It is 1 meter by 2 meters. There are 6 pockets total, 4 in the corners and 2 out in the midpoints, so we can see those. We've got the corners there, and we've got the 2 midpoints there and there. Okay? Now, I'm going to start highlighting vocabulary that I think is important. I think this word midpoint is going to end up being important later. A cue ball is placed 0.25 meters from the north wall and 0.25 meters away from the west wall. The angles formed as the ball approaches and deflects form a mirror image of each other. So in other words, these two angles are congruent, which is going to be important in a minute. At what distance x from the southeast corner should the cue ball hit the east wall so that the cue ball sinks into the pocket? So they're looking for this x right here. This length right here is our final answer. Okay? And let's go ahead and label this pool table. So we know that this length is 1 meter. We know that this total length is 2 meters, or width, I suppose we could call it. But we also know that each of these halves is 1 meter because, again, those pockets here are the midpoints of the sides. Okay? Okay. So we know that this cue ball is positioned 0.25 meters away from the top wall and 0.25 meters from the side wall. Yeah? That's what the problem says. So here's what we're going to do. Now watch carefully. I'm going to do this slowly. We're going to drop a perpendicular line from the center of the cue ball to the opposite end of the table. And hopefully what you can see here is that we now have 2 similar triangles. Take a moment and ask yourself, how do we know that these are 2 similar triangles? Just take a moment, take a second. How do we know that they're 2 similar triangles? Well, we have, in both of these, angle, angle, which is all we need. So now, let's look at these lengths. And this diagram is going to get really confusing for a second, but then we're going to remove the triangles and it'll get simple again. Okay? So if this whole top side of the table is 2 meters, and this little chunk here is 0.25 meters, then this side of this big triangle must be 1.75 meters. Okay? We also know that this bottom half of the table here is 1 meter. So what else do we know? Take a look at this side right here, please. The whole side right there. Okay? We've got 0.25 up here. We've got x here. So we need an expression for that side. Well, we know that the entire side is 1 meter, right? The entire width or length or width, whichever, of the table is 1 meter. So these two sides together, the two bottom sides of the triangle, must add up to 0.75 meters for the whole thing to equal 1 meter. So we're going to call this 0.75 minus x. Now again, all three of these added up should equal 1, right? 0.25 plus 0.75 is 1, and then minus x and plus x cancel each other out, so we get 1. So just double checking. So now that we've got this big, confusing, messy diagram, let's extract the triangles and make it look nicer, make it look less intimidating. Here's the small triangle. We know it's a right triangle because the problem says so. Its bottom side is x, and its height is 1 meter. This is the yellow one. Then we have a larger right triangle that has an up and down side of 1.75 meters. Let's keep these separate. And a bottom side of 0.75 minus x. It is also a right triangle. And that is the green highlighted triangle. So now that we have this diagram, the original diagram no longer holds any use for us. We're not even going to look at it because it gets confusing. We're going to use this one. Okay. There are lots, again, of different ways that we could do this. I'm going to go ahead and do 0.75 minus x over 1.75. And I'm going to do x over 1. And again, because we know that the internal proportions of all similar triangles are equal, these two proportions must be equal to each other. Cross multiplication isn't strictly necessary here, but we'll go ahead and practice it anyway. 0.75x times 1 is 0.75x. 1.75x. I don't like where this is going. I made a mistake. Ha! I'm leaving this in the video because I made a mistake, and I hope that somebody caught it while you were watching, because this is super great and this is important. So I'm going to back up a little bit. Take a second. Actually, this is a good experience. This is a good lesson. Take a second, pause the video, figure out where I went wrong. You should be shouting it at your screen. Take a moment. See if you can figure out where I went wrong. Ready, set, go. So this isn't 0.75x. This is 0.75 minus x. I recognized that I was working my way towards getting an answer that didn't make sense because I've done this a lot of times. But if I had continued through that, I would have gotten x equals 0, and x equals 0 couldn't possibly have been the correct answer. So anyway, that was my mistake. So please don't feel bad when you make mistakes. I know I say it over and over and over again, but mistakes help you learn. Okay, so take 2 from the top. 0.75 minus x times 1 is still 0.75 minus x, and that should equal 1.75x. Okay, now we're doing all right. We're going to add x to both sides. Now remember, that is 1x that we're adding. So we get 0.75 equals, let's see, 1.75x plus 1x would be 2.75x. Okay? And then finally, we will divide both sides by 2.75. And we get x equals 0.75 divided by 2.75. I got 0.27272727. Since we are working with decimals, I assume that Khan Academy on a problem like this would be okay with you rounding to the nearest hundredth or something like that. Now, I want you to notice how I organize my work here. Do you see how my work is more or less in a straight column? This bit's a little bit off to the side, but like here's step 1, here's step 2, here's step 3, here's my conclusion. It makes it much easier for me to pick up on making a mistake if my work is organized nice and neat, as opposed to if it's all over the place like I did in, let's see, not that one, like this problem here. This problem here is much more difficult to parse what's happening. And if I make a mistake, it's much less likely that I will be able to find that mistake because it takes a lot more brain power to try to figure out what's going on. Which step is this even? Okay? So being organized actually will help you, and it will help me give you partial credit because it makes it easier for me to see what your thought process was. So going back to the original problem, this ball should be hit approximately 0.28 meters from the bottom side of the pool table in order to perfectly reflect off the wall and into the hole.